Welcome to Think Easy channel. Today we are going to code the problem Sum of Diagonal Traversal of a matrix. Before diving into the solution, let's discuss the question briefly with an example. We'll consider a 3 into 3 matrix with these values. Now we need to calculate the sum of diagonals. This is the first diagonal, that is 4. This is the second diagonal, that is 0 plus minus 6 is minus 6. And the sum of this diagonal is 4, 9 and 3. So the output will be like 4 minus 6, 4, 9 and 3. Let's understand how will our solution work. See, these are the indices of this matrix, 3 into 3 matrix, of any 3 into 3 matrix. Now let's see how we are going to proceed for this solution. First thing is, we are going to consider the upper triangle and then we are going to consider the lower triangle. First, let's consider the upper triangle. That is this triangle. Consider these last elements. That is the last column. If you observe this, 0, 2, 1, 2, 2, 2. We are going to subtract minus 1 and minus 1 to get the diagonal elements. If you do minus 1 and minus 1 here, you will get minus 1 and 1, which is invalid. For 1, 2, if you do minus 1 and minus 1, you will get 0, 1. That is, the diagonal elements are 1, 1 and 0, 1, which is true. And for 2, 2, you will get 2, 2 minus 1, minus 1 is 1 and 1, and minus 1 is 0 and 0. These three elements are valid. You get 3 elements in this triangle. And then we'll add it all. Let's consider the lower triangle now. We have already taken this diagonal, so even the lower triangle is calculated in the same way. There we are performing minus 1 and minus 1. Here we are just doing plus 1 and plus 1. 1, 0. Add plus 1 and plus 1. You'll get 2, 1. And then for this plus 1 and plus 1. 3 and 2, which is invalid. The size is only till 2. And for this you add 1 and 1, 3, 0, 3. This is also invalid. So I hope you have understood this. Let's go to the code. So we are just taking a list to store the result. The list is of size 2 into n minus 1 because we'll get here, observe here, we have 3 into 3 matrix. How many diagonals are present in this? 1, 2, 3, 4, 5. There is 5 diagonals. That means 5 outputs we are going to get. We are going to store these 5 outputs in the list of size 5. How did we get this 5? Is using this formula. 2 into n minus 1. 2 into n is 2 into 3, that is 6, and minus 1 is 5. Now consider x is 0, y is n minus 1. Let's calculate the upper triangle results. Take a for loop in the range n, and x is z, y is n minus 1. That means x is z is, it changes 0, 1, 2 till n. N is always 2. That means we are considering last elements. Put a condition. See, we have not considered the elements which are less than 0 or greater than n minus 1. That means the values of x and y should be always greater than 0, equals to 0 and less than n. And then we are adding these values, these indices, the value of that indices to D. And we are subtracting 1, 1 to calculate the other elements of the matrix. And then we'll get the upper triangle output. For this, what will we get? till here. That means we'll get 4 minus 6, 4. We need to find 9 and 3 now. Same procedure is for 9 and 3. But we have to just add 1 and 1 instead of subtracting 1. X is equals to Z. Here we are considering X as 1, 2, 3, 4, so on, and Y is 0, 0, 0, 0. That means we are considering these elements. The first column elements. We have already filled 4 minus 6 and 4. Now we have to fill from this part. For that, what is the index of this and this? We need to find out. We'll get the indexes using length of D divided by 2 plus Z. We are adding X. We are returning D. That's it. You'll get the output. Thank you.